Alright guys, we're back in the garage because the boat is put away. And I still want to do boat related things, so I have something here for you today. Let me introduce you to the Sherwood water pump from an early 60s, maybe late 50s Owens flagship. That's a wooden boat. And if you're watching this video, you probably clicked on it because you already know that. And what we're going to do today is we're going to solve a couple of problems. First off, I have a leak on this back gasket. And if I tighten it down to where it doesn't leak, the gears rub against these two plates. And you'll see what I mean when I open this up, but I can feel them rubbing, and that's just too close for comfort for me. So what we're going to do is we're going to pull it apart. We're going to show you how it works. I'm going to show you how to make a gasket for one of these things and put it back together. So here we go. Make sure you guys are in just the right position here. That's pretty good. You guys like that? Is that a good position? I just got to take it apart and I'll show you how the gears work. Okay. So we have 4 stainless steel bolts here. Holding on this back plate. This would have been on a V8 engine, either a 283 or a 327 Chevy. Stainless steel bolts. Wheel. There we go. So you can see the gears. So this is where the water is sucked in, and it blows out of these 2 ports and goes into the risers of the motor. The problems I'm trying to solve today is I'm going to remake this gasket, and that's going to be made out of some paper gasket that I have here, and I'm going to show you how to do that. And this stuff's nice and thick, so it's going to clearance these gears a little bit, because currently they're rubbing on this plate, and that's no good. I need a little bit more play in there. And also, this gasket, not only is it too thin, but it leaks, because I can see it, and I don't know if you can, but there's a rip in it. There's a tear in it right here, probably from taking it apart in the past, and we're going to fix that today. So we're going to get this one off here. You can hear the leaf sucker going down the road. So we're going to set that one aside. Now this is an interesting pump. Before we pull it apart a little bit further, check out these gears and check out how they work. So if I want water to flow this way, it's counterintuitive, but I turn the gears this way. Isn't that interesting? To me it is. See, because I would say that water would squish through the gears this way, similar to the way an old washing machine with the 2 clothes squeezing rollers would do, but not true. So the gears, what happens, because there's always almost a perfect seal between these 2 gears here, nothing can really pass either way, even though it's moving. So it allows pressure to build in these two cavities here. So when water comes in this way, it trucks the water around the outside of the gear in between all of these sprockets, and then builds pressure over here and squirts the water out of these 2 ports. It can also work in reverse, so that's kind of neat. So that's just something like, I kind of think this pump is really neat, and these things are really dependable, and they prime really well. And this is the way it would pump properly. If we pumped it this way, it would suck water out of the motor, and that would be ridiculous. So wouldn't want to do that. So what I'm also going to do is just to show you guys, and we want to check everything for wear. Oh good, the gasket, you have to be careful. See, we're going to save this gasket because what I don't want to do is tolerance it too much. I don't want to make too much play in between these gears. So the problem I'm having now, and that gasket looks nice, and we're going to leave that right on there. I'm not going to fuss with that too much. The problem I'm having now is when this plate goes on and these gears turn like this, I get some rubbing here that I don't want. I want more space so I can tighten it down more, and it turns like that instead of binding a little bit. If I pull this back apart, oh, it's kind of suctioned down there with grease. There's a little grease zerk right here. When you twist this, this cap is full of grease and it automatically greases. Kind of neat. This one just comes right out. And look, there's the same wear as back here. Not as bad, which is good, because I think this bearing assembly in here kind of protects it and pushes it out. But these things are not worn. They look really, really nice. Nothing seems excessively worn. Everything's tight. The bushings are tight. So that's excellent. That's excellent. So what I'm going to do is set. Well, we're going to have to take that gasket off. We're going to set that aside for now. We're going to have to remove this gasket. And oh, it does. It's okay, but it's got a little bump in it right here. That gasket does. This thing's been assembled and disassembled a couple times. I'm going to still try to save this. I think it's going to be okay. Yeah, I think it's going to be okay. It does have just right next to the screw. It's got like a little, but I think that's going to be okay. We're going to set this one aside. We're going to be real gentle with it. Just because I don't want to wreck it while I'm using this as a template to make my new gasket. So I'm going to set you guys up on a different cam here, and, or just a different position with the same cam, over by my vise, and I'll show you. I'll start, and I'll show you how to make gaskets. And this is really cool. I'm not going to have to talk a lot. You're going to kind of just get it. Alright, so I have you guys into position. So our first step is to take our gasket material and just get an idea of a piece that we can cut off and use for a gasket. This gasket material can be purchased from just about any auto parts store. I believe this one is referred to as a paper gasket, but there's other materials for other applications that you can do the same thing to. You can use this same technique to make gaskets. So I have my piece, kind of have it laid out, and what I'm going to do is very carefully, I'm going to use a little ball peen hammer, is kind of the best way to go about this, and I'm going to get my lineup pin decided on it. I'm not going to pound real hard on this lineup pin. Make sure I have enough overlap. I'm just going to tap on it enough to get an imprint. I don't want to take the chance of pounding that in, perhaps, so I have a little imprint. I'm going to use the knife to cut that out. Yep, a little hole for our lineup pin. It's actually, there we go, it's a pretty tight fit, but that's okay for now. Enlarge that later. I like the fact that it's details on here. And from here on out, well, first, you know, what I like to do is kind of just rub the thing down and get a little bit of a shadow, so I kind of know. Break the edges of the gasket over the casting, and what that'll do is just give me a little idea of where to use the hammer. And from here on out, I'm not going to talk too much. I'm just going to work my way around this, and you're going to notice right away how this works. So start at the top, ladies and gentlemen. There she is. Now I've found this to be a really handy little trick as a boater, to be able to make your own gaskets like this, and they're fairly precise. That's a decent little gasket, and I didn't do any damage. I'm very careful about that. No, she looks real nice. Alright, well, let's put her back together. Get your back over here. So, scraps off to the side. We have our new gasket to replace our old one. And not only is it not broken, but it's thicker. And that's going to leave us some clearance for our gears over here. So we'll just go ahead and put that back together, and we'll test it out. We'll bench test this thing and make sure it works. So that can stay in there. I do need to use this gasket. This gasket I'm going to put on this side because it's older and this side won't be taken apart as often as the other side. Give the other side the new gasket, but it wouldn't matter. I may be making a new gasket for that at some point. It's not in the greatest of shape, but it is good enough, I believe. Figure out 2 alignment pins. Very careful. Oh dear. And she all comes falling apart on us. No big deal. There we go. So that seems to fit together nice. There's not really any play in that. A new gasket, just like we had it on there before. You'll notice a hole here. I didn't make the hole for this here. This is there should be an alignment pin in there. I don't know if this was a modification, but now there's a drain plug, and it leads only to a chamber where there's already a drain plug, so I neglected it, and we're going to just leave it that way. go. One's put together. The bolts on. Oh my shirt. Gee whiz, I like this shirt too. It's one of my favorites. I'm gonna have to have Patty put some Fells Naphtha soap on that. That's what she does. I guess that works. I hope she can get that out. I'm just gonna take this off in a minute. Oh, there we go. Nice little tighten down there. Just a little bit all the way around. I'm not going to tighten it a lot. And then if it leaks, I'll tighten it more. I'll go around a couple times. A little snug. A little snug. That's it. She's all back together. Let's give her a spin. Oh yeah. Nice, no rubbing, and I got her tightened down pretty good. So, next up, so let's bench test this thing. Now that's going to take a little bit of doing to hook up some plumbing and whatnot. So let me get that done. And we'll go from there. Alright, so here we are, ready to bench test our Sherwood water pump from an Owens flagship, either a 283, 327, early 60s, maybe late 60s or late 50s on the 283. I'm not really sure, but so what I'm going to do is hook a drill up to this, and I have rigged a way to prime the pump, which it's already primed. All that needs to happen is water's just got to be filled up to here, and these hoses are currently empty. So water is going to enter this hose here. You can see it's in the bucket, and obviously enter the pump, and you'll be interested to see which way we have to spin the drill to get this to pump water. So if you remember when we had to break this, when we broke this thing down, the gears and the direction of the water and the pump action, pretty neat. So keep that in mind. And so I'm going to set you guys up. I'm going to get my drill. Maybe, I know it's just backlit like crazy. I think the answer's right here. Although this is going to be a bear to get out. The garage has got a corrugated metal roof on it, and this is just a piece I keep around because if I ever had a puncture from a tree or something like that that needed to be just patched, I keep a little piece around. Sorry about that. That's better, I think. Maybe. A zip tie here. This will allow you guys to see how this is, which way this is turning. And then tighten the drill down. So if you remember the way those gears turn, and you see the way I'm turning, it's kind of counterintuitive, because if you envision those gears, the shaft is on the bottom gear, and the top gear is on its own little shaft here. So turning this way, so if you envision like one of those old washing machines with the two rollers, you would envision these gears rushing the water this way through the device, but just not so. It's actually the opposite. So the way the drill is turning, if I spin the drill the other way, it actually is blowing bubbles down here. So right now this hose is empty, so let's turn it the other way and see how long it takes to prime. And I'm just going to give her. I'm going to go full on, And then we'll see if we can do it at slower speeds and just see what the capacity of this pump is. So here goes. There she goes. That's a good stream. That's a good stream. And you can see kind of counterintuitive the way that spins. Let's slow it down and see how slow we can go and keep pumping water. Oh. That just pumps less water. It'll just trickle it, I guess. What'll it do like this? Nah, it's gonna lose prime there. You imagine, you know, an engine idles at 600 to 700 RPM, so. And this thing's on a huge sprocket, and this is a small sprocket, so I would not know the math exactly, but I could imagine this thing turning at 2,500 RPMs even when your engine's at an idle. Imagine how fast it's turning when you're cruising along at 3,000 or 4,000 RPM anyway. No leaks. No leaks. No leaks. Not even in my temporary plumbing that I rigged up here. Alright. Well, that's it, folks. That was the bench test, and she works, and end of the movie. Thanks a lot for watching.